All right, welcome back. And today we are going to do a question called distribute bonuses. All right, let's read the question. You are the manager of a number of employees who's all sit in a row. The CEO would like to give bonuses to all your employees, but since the company did not perform well this year, the CEOs would like to keep the bonuses to a minimum. So the rules of giving bonus is that each employee begins with a bonus factor of 1x, okay? For each employee, if they perform better than the person sitting next to them, the employee is given +1 higher bonus and up to +2 if they perform better than both their sides. Given a list of employee performances, find the bonuses each employee would get. So for example, this is their performance. So this guy's a rock star. He has a 5x performance, or the number 5. This guy sucks. This guy also sucks. So this is how good they are. And then basically what you want to do is, for someone who's good, you want to make sure that if the two sides, if that person is better than the person beside him, then you better pay him a higher bonus, right? But we want to minimize the bonus. So for example, if he doesn't know that far along the side, there's a guy that makes like 3, for example, but then he's better than both guys, then he's always just capped at whatever money he's gonna get. I guess what I mean by that is, let's say they can only talk to people beside them, and they only know how well they perform at their company comparatively to the people on their side. So that's pretty much what the CEO is talking about. Let's look at the input and output. I think it's a lot easier to explain if we just look at this. So 1, as you can see, he's going to get a bonus of 1. 2, because he's better than the guy at 1, he has to get paid more than that guy. So he got paid 2 instead of 1. Why? Because he performs better than the guy who just performs at a 1, right? And then this guy, he's better than both the left and the right employee. So he has to have 2 bonuses. So instead of 1, he gets an extra bonus factor twice. So 1 + 2 = 3. And then this guy performs at 2. However, unlike this guy has 2 high performers next to him. So he knows that he's the shittiest amongst his neighbors. So then he deserves a 1 because he wouldn't know any better, right? And then this guy, even though he's a 3, he's not going to get 3 because he has an even higher performer next to him, which is the 5, which is why he gets only 2, right? So that's pretty much it. That's the basic of the question. So now let's think about how we can do this. All right, so let's go to the whiteboard and let's think about this. Okay, so what we have now is these are like the people, the employees, and then you have their performances just like before. We're using the same example. And then what you want to do is you want to make sure that the bonuses reflect how they perform. All right, so what we're going to do is we're going to iterate this way. And then let's call this the left iteration. And the reason why is we're always going to be looking at the left and see what kind of bonus it has or what kind of performance it has. So for example, let's start them at all 1s, because for now, everyone gets paid the same. And now we're going to fix it up by looking at our left. So if we look at our left and the performance is better, then we're going to add a 1 to whatever this number already is, because we know that we have to be paid more than the person next to us if we perform better, right? So for example, here we see that's bigger, so it's +1. So we add this guy here. And we add +1 to whatever the guy on the left makes, right? So for example, if it's this guy, then it's also bigger, so it's +1. And then this guy makes 2, so now this becomes 3 because 2 + 1 = 3, right? And then this guy does not get any bonuses, does not get any increase in bonus because it's not bigger. This guy is bigger, so it's gonna add +1. So we're gonna get 2 here. And then this guy is also bigger, so it's gonna be +1. It's gonna get 3 here. And then this guy does not get anything special. Okay, so this actually already works out, but usually what you have to do is you also have to go to the right. You have to go like this, and then you want to make sure that whenever you look at the right, like this, you're gonna have to check if you're better performant. If you're better performant, you're just gonna max yourself plus the one on the right. The reason why we do that is because we know that we have to be, like, if we're better than the guy on the right, we have to get paid more than the guy on the right. But we could be already been paid more than the right, so that's totally fine, right? Okay, so here's how we do it. We call it right. So we essentially do the same thing. We look to the right. Should we add a +1? Yes, we should, but we're already bigger than 1 + 1, which is 2. And then 3, we look at that, it's not bigger. I'll just add +1 here. Here, is it bigger? No, it's not. Here, it is bigger, but 3 is already bigger than 1 + 1, so it doesn't change anything. This is not bigger, this is not bigger. Cool. So yeah, so that's pretty much how you do it. Let's think of an example where this would actually matter. All right, here's a small example of why we had to go to the right also. Like here, it's all decreasing, right? So if we go, if we look to the left, then it's always gonna be 1, 1, 1, 1. Because you keep looking to the left, but you're not gonna get any +1s, right? But clearly that doesn't work. So then what we're gonna do is we're gonna have to go to the right side. You know, we're gonna have to go this way and then look at the right guy. So I'm gonna look at my right. Am I bigger? Yes, I am. So it becomes 2. I'm gonna look at this guy. Am I bigger than this guy? Yes, I am. So it's gonna be this guy. And then here, 4 is actually bigger than 3. So then it becomes $4. Yeah, so that's pretty much it. All right, so let's do the code for it. Oh, actually, let's think about the time complexity and spacing complexity. So the time complexity would be O(n) is linear because you have to do 2 passes, and that pass is basically n because you have to go through the whole array. The array is size n. And then the space complexity is O(n) because that's the extra space you use to add the bonuses, which is basically also your output array. Okay, cool, so let's do it. So first, what we want to do is I just want to count how many employees there are. So we just count here. Oops, performance. Okay, and then you make your bonus array, which you initialize all at 1 in the beginning, and then they all have 1. So then let's go from left to right, and then we're always going to look to the right. So for I in range, we're going to start at 1 because we don't want to go out of range, because if you start at 0, you don't have anyone on your left. Okay, so then now what we're going to do is if our performance is actually better than the weakling, which is I -1, so performance I. So I -1 is basically the guy on my left. And then if I'm bigger than that person, then I want to be paid more than him. So bonus I -1 + 1 + 1, right? I want to get paid more. Cool. And then that's pretty much it. And then for the other way, we're going to start here. And the reason why it's because, like I said, I don't want to go all the way to the right or else I'll go out of index. And then I'll do -1, -1 because we're going backwards. All right, if performance I + 1 is smaller than performance I. So that means the guy on my right, if I'm bigger than the guy on my right, what am I gonna do? I am going to do the max of myself already, if I'm not already the biggest, or the guy to the right +1. And then that's pretty much it. And then you just return the array. Let's try it out, see if it works. It's supposed to give us this. Int has no object bonus. Oh, whoopsies. Okay. All right, so here you go. We have the answer right here. So that's pretty much it. And yeah, thanks for watching, and I'll see you next time.